Every food is cooked with heat, always getting brown. Either it is a juicy T-bone steak or even this fluffy pancake. Do you know why? This is how science works. When food is getting brown, it is not only because of heat. Normally, there are two types of food browning reactions. The first one is enzymatic browning, which occurs when enzyme in food is catalyzed, like your apple are getting brown after cutting. When cutting apple, the cell wall is broken and allow PPO enzyme and oxygen to react with monophenol in apple cell, then generating new brown substance to appear on apple surface. How can we avoid this? Just stop their oxidation activities. Soak it in salt water or syrup, or poach them. Salt or sugar particle will coat the apple surface, preventing them from interact with oxygen, and poaching can kill PPO enzyme. They are not be allowed to work anymore. From this experiment, we leave 3 types of apple facing the air in almost 1.5 hours, and you see that it's help. Then what about non-enzymatic browning? The second type of food browning reaction. It can occur in 2 ways, Maillard reaction and colorization. Now it sounds more complicated. Did you remember your steak and pancake? It's a Maillard reaction. This kind of browning occurs when sugar combines with protein and then heat up. The more protein and sugar is, the more brown your food will be. Let me show you some fun. These are pancake batter contain different ingredients. The first one has only cake flour and water, the second one has both with added sugar, and the last one has all with additional egg. Every batter has the same ingredient ratio and is cooked with the same heat in the same period of time. After cooked pancake, this is how they look like. Maillard reaction is a chemical reaction that happens when reducing sugar, an amino group of protein made in food, and heat up. After that, generates a new component called glucosamine. When continue heating or cooking, glucosamine starts to form new complex brown structure called melanoidins that give brown color on food and also generate volatile compounds giving a nice smell, such as frulan, meaty caramel-like smelling, pyrazines, roasted and toasted smelling, and payrols, nutty-like smelling. Let's get back to our pancake experiment. Actually, cake flour composed of many sugar molecules bound together in a starch globule. That's why you can see some browning on the first pancake. But for the steak and pancake, it looks more brown because sugar that you add. The added sugar is easier to dissolve. It is floated around other ingredients, which is very easy to start reaction, so it is look more brown. Then what about this beautiful pancake? It have got the most browning color because of the protein in eggs play a role in the reaction, so the Maillard reaction happen. As you can see, Maillard reaction can happen on every type of food, from roasted pork, pancit snowfish, or even baked goods. But not with this creme brulee. The crispy brown surface on this creme brulee is not from Maillard reaction. Our chef sprinkles sugar on top of the smooth cream custard, then burn it. The sugar is getting brown and starts to form crackable surface. This is colorization. The process that sugar transforms its component into stronger structure when getting heat. When syrup boils and reaches 160 degrees Celsius, the molecules are decomposed and broken into smaller monosaccharides, glucose, fructose, and volatile compounds, like the volatile compound that we found in previous Maillard reaction, meaty furans, roasted like pyrazine, and nutty payrols. When heating is continued, each individual sugar molecule starts to stick together again. This process is called oligomerization, which generates new brown glucose polymers in caramel products, such as this crispy top creme brulee What does caramel gas do? This is how browning reaction happens on food. Next cooking time, be careful your sugar and protein.